So we're going to graph cosecant. To start that, we're going to graph sine. Sine starts at 0 and quickly rises to its peak, then goes to its lowest point, and then ends back at 0 where it started. But, Mr. Server, that's just sine. I thought we were graphing cosecant. Well, you have to start by graphing sine, and then remember cosecant is 1 over sine. So that matters because, well, whenever sine is 0, like here and here and here, that creates 1 over 0. What's 1 over 0? Doesn't exist, so you put asymptotes in here and here and here. All I still have, though, is I still have sine with some asymptotes thrown in, which doesn't make any sense because you can't go through asymptotes like that. So these loops are the final piece to the puzzle. Who had them and was done before I finished? Okay. So that's cosecant. I'm erasing sine out now. Now, if I left it this way on the test, I wouldn't get any credit because I didn't label the x and the y-axis. This is an important part. They all go through 1 and -1. I'm going to say that again. All of the functions. Sine touches 1 and -1. Cosine touches 1 and -1. Cosecant touches 1 and -1. And tangent and cotangent that you haven't even learned yet, those will all go through 1 and -1. So that's why you have to have them here. They're super critical. Okay, and then these, for sine, which is what we graphed in the first place, you count by 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. And I said this is like the only time when I will forgive not reducing. All of the tests, if you don't reduce something, I have to mark it wrong. But for this test, I think it's smarter to leave 2 pi over 2 that way. You don't have to. You can reduce it to pi. I'm not going to mark it wrong. But it counts so nice. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Why does that matter? Because right now, I'm about to tweak something. Everybody put a 3 right there. If you put a 3 right there, we'll just have to do something to cosecant. And we take this original graph and do one more thing to it. We've graphed cosecant. Now we've got to stretch it or shrink it. Well, you never trust the stuff on the inside. So it's not going to multiply it by 3. It's going to multiply everything by 1/3. Go ahead and do that and get the final answers for me. And you'll realize if you count it up the normal way, like 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, that they make a perfect little set. Pi over 6. What would the next logical one be? 2 pi over 6. And that's what it is. If you look at this, it's 1 times 2 is 2 pi over 6. And then you shouldn't even have to look at the other one. You just go 3 pi over 6, add 4 pi over 6. Once again, if you reduced them, it wouldn't flow nice. It'd be pi over 6, pi over 3, pi over 2. That doesn't even make any sense to me anyways. And then 2 pi over 3. Great. There's no way that these flow. These flow really nice. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Okay. One last thing, and it would be super simple to just squeeze in a 7 in front of the cosecant. Do that. And we'll just have to change one little thing. The numbering on the y-axis, since it's going to be 7 and -7. That is as complicated as we could make it on the test. We'll never do more than 2. No, wait, I shouldn't say that. what we said was we would never do two changes even on the inside. So the inside will only have one change, like that 3 right there. The inside meaning this part right here. We'll only do one change in there, but we will often do another change on the outside, and I guess our rules don't preclude that we could also, I'm not going to do it, but if I could put like +1. If I did, do you get the whole graph would move up 1? All right. So we could do as much as 3. Usually we do 2 changes on a graph. All right, so let's see if you really got that. That was cosecant. The other one that you learned was secant, which rides on its sister's back. So let's make 5 secant of theta, but then we're going to shift it to the right pi over 2. Do this one thing at a time. Don't even start graphing secant. Graph the sister to secant, which is cosine. All right, I'm going to pause for a second. Let you give that a shot. To make sure you started on the right foot here, this is cosine's sister. Cosine is the big valley. Cosine, unlike sine, which just shoots up, cosine just drops like a rock. It just keeps dropping all the way until it hits 0. And then it comes back and makes a big valley. I said an always thing, which is really rare in math. Sine, cosine, secant, cosecant, and tangent and cotangent always touch 1 and -1. So if you don't have these here, you don't really understand it quite yet. And then I said I would always count up. 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. It's totally fine if you leave that as 2 pi. So then what's the period of this? Well, it's 2 pi, or 4 pi over 2. Period means 1 complete cycle. Did I change that by putting a number in front of the theta? No, I did not. So the period is still 2 pi. But wait, this is just cosine. You're right. But the same thing goes with secant. If there's no number here, then its period's still 2 pi. All right. What does this 5 do, and what does this secant do? Well, secant, first off, is 1 over cosine. So that means when is cosine 0? Because if it's ever 0, then this new graph will be 1 over 0. So that causes asymptotes there and there. That's one of the reasons you want to graph cosine first, is to find out where cosine hits 0, so you can make it 1 over 0 and therefore an asymptote. And last but not least, you make the loops. It rides on the back. And in the old days, we were strict about this. We've softened up. I did it that way because I wanted it to have a hard stop so that it would have exactly 1 period of cosine. But on your test, we will allow you to keep going because kids so often wanted to keep going and they would do this. And we will accept that. But it is more than 1 period. Do you get that? Because there's 2 upper loops and there's only 1 lower loop. It's not a complete set of 2 cycles. It's only 1 cycle plus a half. So bottom line, for you perfectionists, that is not 1 period. It's more than 1 period. If you really only wanted 1 period, you'd only want that part, because that's got 1 up and 1 down. And if you're really a perfectionist, there's a lot of things to not like about this. It also needs an asymptote line in there, but as long as you have asymptotes, you've labeled the x and the y-axis properly, you'd be okay. So far, all I've done is graphed secant. What about the 5 secant? Brady, you know what I should do with the 5?
With the y-axis of this 5.
This is a 5, and this is a -5. You are correct. That's what you do with the 5. And then there's one last thing, and it's the hardest part. Somebody step up.
You multiply the x by 2.
I get what you're thinking. You're thinking, oh, I'm going to divide, instead of dividing by 1/2, I'm going to multiply by 2. But this is a move to the right. This is called a phase shift. Thank you for trying, but we are not going to change these numbers. If I would do that, if the 1/2 was in here, that's when I would do that. This 1/2 is different. It's a phase shift. Everything needs to shift. Well, first of all, do you know if this is a right or left shift? Negative normally goes to the left, but remember we're on the inside, so it's the opposite of left. It's to the right. That is a shift to the right of pi over 2, and every single thing, the whole graph, needs to shift 1 notch to the right, because this is how far pi over 2 is, see? So it's that far that everything needs to shift. This needs to shift over that far. The asymptote needs to shift over that far. The top of this needs to shift over 1 notch. Everything shifts over 1 notch. Everything. It is going to be really hard to draw this and not have it be messy. So I'm going to just redraw it down here. And I'm going to start with the asymptotes. The asymptotes have moved to here. And here, which is above 2 pi and pi. And then the loops have moved. The base of the loop used to be here, and now it's going to move over 1 notch. So the base of the loop is there. Whoop. And this base needs to go over 1 notch, so that's right there. And there is my... if I had gotten this far, I would cry a little bit for the kid because he forgot to label the y-axis. On my y-axis, I'm supposed to have 5s because of that 5 in the front. 5 and negative 5. There. Now that would have sufficed. I would really ideally like the kid to have labeled all 4 spots. But I think I could have let them get away with having only 2 of them labeled. That was pretty intense. Yes. Okay. I think you have plenty of time. Go for it. Okay. All I've done is review Friday. You were supposed to learn all of that on Friday. I hope you watched that video, and I hope you did learn that, and I hope you practiced it on the homework. But now I gotta move on to tangent and cotangent. So what's tangent look like? Everybody just draw this graph. Do you remember the y equals x squared? No, x to the 3rd graph? Kind of looks like that. Except the y equals x to the 3rd graph would go forever in both directions. Like you keep on putting bigger and bigger numbers in, it would keep moving forever. Tangent looks like that, but it's actually got asymptotes here and here. So it cannot cross those. It'll get closer and closer to them, but never touch them. So it's like x to the 3rd, but it's limited. And just like on the other ones, we count by pi over 2s for each mark. But if I go, and this is 0, and I go back over to this mark over here, that'd be negative pi over 2. That's what tangent looks like. And you want to do more periods of it, you just keep making them. So I'd go over, and I'd draw another one over here, and I could keep doing that if I want to, because it goes forever. But it has a period of pi. The other ones, up until today, every single thing had a period of 2 pi. But this has a period of pi. Let me show you why. It goes half of a pi in this direction and half of a pi in that direction. That's a total of 1 pi. So its period is 1 pi. So I kept giving you this formula. Period is 2 pi over b. But that was a temporary, only worked until now. Because now the period's pi over b. So if you squeeze something into tangent, like tangent of 5 theta, then you'd say its period would have been pi, but that 5 changes it to pi over 5. Okay, so what's the period of tangent? It's pi. If you want to change it, you change the b term, and then you divide by that. Okay, that's tangent. And now let's do one that's a little more complicated. Y equals 3 tangent of 4 theta. It's one thing at a time. Xavier, what do you think I'm going to tell you to graph first?
The main line.
Yep, main one. One normal tangent. Who remembers where those are? Nope, that's this and this. Good try. Pi over 2 and negative pi over 2 is what I was looking for. You are correct. This is 1 and negative 1, so those should be included on your graph, so you're right about that. Now, I remember him saying it kind of looked like x to the third. I hope you drew in your graph kind of like that. And I'd be good, except for, that's a 3. Ethan T. That 3 in the front, it's called the amplitude. What does it change on my graph? Correct. They become 3 and negative 3 instead of 1 and negative 1. And last but not least, this 4. The period would have been pi unless you have a b and then you divide it by b, and then I do have a b, and so I divide it by 4. The period of this thing is pi over 4. So that means I got to renumber something. I hope you're like, go, oh, maybe I should times everything by 4. Oh, wait, no, you don't trust the inside, so I should times everything by 1/4. But you can't leave me a math problem. You actually have to do that. Pi over 4 times 2 is 8, and this must be negative pi over 8 then. And that would be a typical test question. Do you think you could do that? Let's find out. Everybody, let's do one more with normal tangent before I switch to cotangent. Normal tangent, except it's going to be tangent of 4 theta minus 1. Notice that's the inside is the 4. That minus 1, that's on the outside. One thing at a time. Start by graphing regular tangent. Dominic, tell me some of the stuff you know about regular tangent. What are they at? Do you remember? Nice. Regular tangent goes like this. Do you have to label the 1 and the negative 1? Yes. It's a big deal because they all touch that. They all go through 1 and negative 1. And last but not least, that's regular tangent. Now I got to do these transmutations, basically changes. Rissy, what does it 4 tell me to do? 1/4 on each of these. And Morgan, What does this plus 1 mean? That's right, it's a minus 1, yes. What does that minus 1 mean I should do? Everything goes down 1. The asymptotes, it's kind of nice, they don't have to move. Because moving them down just keeps them right on top of each other, so they're fine. But this needs to go down, and this that was at 0, 0 needs to go down 1, and this that was right there needs to go down 1. And I would make 3 new dots, and then I would try to draw my graph through those. And my final answer is the red one gets shifted down to where the blue one is. So the blue one would be my final answer. Oh, and I should make this into pi over 8. I'm sure you did. A negative pi over 8. Okay, so there's tangent. Last but not least, cotangent. So this is the last trig function that you could be asked on the test, which is on Thursday. Today's Monday. Tomorrow we have one last little thing where we give you like a real world problem that involves sine and cosine. So tomorrow is like applications, and then Wednesday's review and Thursday's the test. Thursday's also the first day of conferences. So I'm trying to give you a motivation to try hard for the next 3-4 days. Why? Because you're going to take the test on Thursday, and then your parents are going to come to conferences. My keyboard. I will then give them a shorter review of how you're doing in class. Like, yeah, he's got an A in class. Sometimes he's a little late. So talk to him about, showing up too late to class or whatever. And then I'll say, and he just took a test today. Let's grade it. So I'll be grading the test live and in person with your parents. So bottom line, how about you try hard on this test? Because it'll be graded live in person with your parents. That's the plan anyway. All right, so let's say it was about cotangent. You don't even know what it looks like yet. So take good notes. Cotangent has asymptotes here and here. It's shifted over. Notice it's not the same as tangent. Of course it's not. The big difference is that it's shifted over. And then it looks a lot like tangent. And in fact, some of you are going to be like, isn't that exactly the same as tangent? Nope. It's technically flipped. It starts going down and it goes down the whole way, if you think of it as from left to right. Whereas tangent was going up the whole way. That's cotangent. What did I say was on every single trig function? They go through what and what? 1 and negative 1. So just put a dot, however high you say 1 is and however low you say negative 1 is. And then the last thing I would have to have is labels on the asymptotes. Like I need x-axis labels. Well, 0, 0, you don't even have to label because we know where 0, 0 is. Then that leaves us with one thing. And a lot of people are going to say pi over 2 and they're going to be wrong. That's where pi over 2 is. 1 mark over is pi over 2. So then what's the other one? 2 pi over 2. AKA pi. Now, I said tangent and cotangent had a different period than all the other ones. All the other ones were a period of 2 pi. What's the period of this one? Pi. Because look, it finishes up between 0 and pi. So its period is pi. But I thought you said there was b. Yeah, this one's period is pi. But if there was a b term, it'd be pi over b. So if there was a 5 here, you'd have to multiply everything by 1/5. That 5 would go there, and the period would be pi over 5. So again, 1/5 here, and a 1/5 here, and a 1/5 times 0 is still 0, so. And if I threw in a 6 here, I'd throw in a 6 here and a 6 here. That's the easiest kind, is to change the amplitude. All right. Now you've learned every function. You've got a lot of time left in class. So what do? Well, we're going to do one more that kind of makes sure you understand tangent and cotangent, because there's the new function for today. And then I'll start the homework with you, and I'm going to really, really hope that you take the homework tonight seriously, more seriously than normal, because The test is coming, and it's conferences week. So even if your parents don't come to conferences, they're going to be hearing about them. The principal's going to send out like 3 emails saying, come to conferences. And they'll be like, well, I'm not coming, but maybe I should look at their grades. So like this is a really important time to be doing well. And also, if you're missing this assignment and the assignment I give tomorrow, that's the ones I'm going to be talking about because they'll be like, well, I haven't done homework for the last 3 days. That's a great way to start conferences. So bottom line, do your stuff. It's a good week to really be on top of your stuff. All right, y equals cotangent. Just cotangent? No, cotangent of 4 theta plus 1. One step at a time. First, figure out what cotangent looks like. Remember that the asymptotes are here, here. Then you'll change these x numbers and the y numbers. Well, actually, the y numbers don't change. Label all that. Then don't forget the plus 1 at the end. I'm going to pause while you give this one a shot. Act like it's the test. Okay, this was 1 and negative 1. If there had been a number here, I would change them, but there isn't, so those get to stay the same. This was 1 pi over 2, and this was 2 pi over 2. And I don't have to keep numbering. So I now need to change that because of this 4. So they get multiplied by 1/4. And this becomes pi over 8 and 2 pi over 8. Yes, you can reduce it, don't have to. All right, and then cotangent is the one that falls the whole time. As you read from left to right. My curves are never perfect on that, but I would accept that from you on the test. And then that is where it hits 1, and that's where it hits negative 1. And last but not least, this plus 1. Everything needs to move up 1, and you know how far 1 is. If all you did is like go up a little bit. No. Look, we know that that's how high 1 is. You have to move it that far. Whatever that distance was for you. So all of these key points move 1 notch up. So that will touch right there. And I think the best way is to make 3 new dots and then make your graph fall through those dots. And my blue one is the final answer. It's been moved up 1 notch compared to the red one. All right. How many of you feel like you can handle this? You've got tangent, cotangent. Okay, that's almost everybody. Yay. So then they could ask you questions like, what's the amplitude? And it's, don't overthink this. It's a number. Say it if you know it. 1. It's the number that's right there. 1. Default to 1 if you can't see any number there. Okay. The next thing is, what's the period? Well, what was it in the first place? Pi. But in this case, we do something with the pi. We can't just say pi. It's pi over b. So it's pi over 4. Another thing I could ask is, was there a phase shift? And some kids get tricked because they're like, oh yeah, I shifted it up. That's not a phase shift. A phase shift means a shift to the right or the left. This one did not have a phase shift. And they could say, what's the domain? That would really be a weird question in this case, because the domain is everything it can be from left to right, and there's lots of things it can't be because of the asymptotes. So it's actually kind of complicated. Wouldn't probably ask you the domain, because it's like a ton of things can't be when as you move from left to right because there's asymptotes there. But the range would be an easy one. If you look at this graph, what's the lowest it can go to? Infinity, but low infinity, so negative infinity to infinity. That would have been the range of this one. All right, now problem 1 on your worksheet. We're going to do 1, 3, 5, and 7, and I'm just going to do number 1 with you to get you started. And then after that, it'll be on you to take this home, finish it up, take it seriously. There's little follow-up questions, and those are important too. Hudson, would you read me number 1, not the whole thing, just the start? So is it cosecant between 0 and 2 pi?
Yeah.
Okay, thank you. All right, so here's cosecant. Psych, I'm not gonna even start with cosecant, I'm gonna start with sine. And then I label all the things. Is it cosecant? Number 1 is tangent? Are you on the wrong worksheet? Okay. Sorry. Then eventually you'll need to do this. All right. Number 1 is actually tangent. Tangent. Is it just plain tangent? I now am like scrambling because we started graphing the wrong thing. Winston, would you verify that number 1 is graphing tangent? Okay. So then asymptotes go here and here, and it should be pi over 2 to negative pi over 2. And there's tangent. What am I missing, Graydon? Yes, and they always are 1 and negative 1. And it, put a dot where it seems to cross that. Cool, there's tangent. Did they do any changes to it? Okay, so it's early on in the worksheet. They just like, oh, the kids barely learned tangent, so we better just start with that. Then there's part A was to graph it. What's part B, Graydon?
For what values does x, or for what values of x does tan x equals 0?
So where is tangent 0? Tangent's that black line. Where does it hit 0? At 0, 0. That's the only time that black line is at 0, is at 0, 0. About part C, Graydon.
For what values of x does tan x have vertical asymptote?
The vertical asymptotes, I labeled them already, so that'll be easy. But when you're putting an asymptote, you always have to say x equals or y equals. These are verticals, which are zertical, like x equals asymptotes. Don't just say pi over 2 and negative pi over 2. You got to say x equals. Otherwise, you're not labeling an asymptote. You're giving a bald answer. Without the x equals on the AP test, that you would have got this wrong. And part D. Maren Sabins, can you read me part D?
For what values of x does cosine x equals 0?
Cosine. Yeah, it's the correct question, but it is weird because we've been talking about tangent, and all of a sudden cosine. When is cosine equal to 0? Well, I better graph cosine quick. Cosine is the valley. And where does this graph touch 0? I'll call it out as big black dots. There and there. So you got to figure what those are called. I hope you know all 4 spots, and then you'll know where cosine is 0. Why does that even matter? Well, because later when you graph the sister function, there will be asymptotes running through here to graph secant. So that's why those matter. Okay, do problems 1, 3, 5, 7. That cuts it down to a doable size worksheet. The reason we cut it down is not because we think you couldn't handle it, but because you have a lot of things in your life, and if you will do just these, it'll make a huge difference. So by getting some kids, all kids to do some of them, it'll be better for us in the end than like a couple kids actually do the whole worksheet and other people just give up because it's too much. So respect the fact that cut down the homework a lot and do the ones I did assign. 1, 3, 5, and 7. Okay, that's all I got for you for today.